Hello everyone, my name is Hong Zhang, and the title of my report is Deeper Reinforcement Learning for Real-World Quadrupedal Locomotion, a comprehensive review. As we all know, in recent years, research on deep RL algorithms for land robots has been continuously gaining world attention. Meanwhile, some famous research institutions and companies have publicly reviewed the implementation of DRL-based land robots. So there are some typical quadrupedal locomotion studies based on DRL algorithms for 2019 to 2022 years. A common method for DRL-based quadrupedal locomotion research. This method is mainly divided into training and test phases. The policy interacts with the simulated environment and collect data for accurate update, and then the trained policy is developed to the real robot. There are some results of important papers in the quadrupedal locomotion research from the classification result of the most relevant publications. Although many novel algorithms have been developed in the DRL community, most current quadrupedal locomotion controller designs use model-free DRL algorithms, especially PPO and TRPO. For complex high-dimensional nonlinear systems such as robots, stable control is a fundamental purpose. Most researchers choose PPO or TRPO algorithms for utilization in the research. Over the past few years, hyperbola and Rason simulation platforms have been the choice of the most researchers. Common robotic simulators can only solve control-level simulations, but they are stuck to real-world simulations. Recently, Inradar released a new simulator, ISAAC Gym, which simulates the environment with much higher accuracy and can simulate and train directly on GPUs. Therefore, more researchers began to use this simulation as the implementation and verification platform of DRL algorithm. While the series of animal robots are well known for the high hardware cost, the low-cost robots like Unitrain AE is a more popular choice among the researchers. Lower-cost hardware platforms allow DRL algorithms to be more widely used. Currently, the DRL-based quadrupedal locomotion research is an emerging and promising field, and many people have not been officially published. The published papers are mainly in the journals or conferences related to the field of robotics, and there are 4 outstanding works published on science robotics. Moreover, state action and reward are important components for training controllers. The design of these components will directly affect the performance of the controller. However, there is no fully unified standard and method for the specific design. In current research works, for simple tasks, internal state alone is sufficient to solve the problem. But for more complex tasks, the external observations such as visual information need to be introduced. Most researchers would consider user desired joint position as the active space, and then calculating the torque through a PD controller to control the robot locomotion. In general, the design of the robot function is fairly laborious, especially for complex systems like robots. Small changes in the role function hyperparameters have the potential to have a large impact on the final performance of the controller. Many works also consider additional information such as trajectory generators, control method, and motion data. Under the current Machine learning methods, the road gap is an unavoidable problem that must be addressed. In the DRL-based real-world quadrupedal locomotion field, open problems may include super efficiency, generalization and adaptation, particle observation, and road gap. Based on the current research data of quadrupedal locomotion, we explored the future research prospects from multiple perspectives, in particular, where model skill data and pre-trained models require significant attention, as this direction will play an important role in realizing lagged robot intelligence. Okay, that's all. Thank you for your listening.